So good morning, sir. Dr. VEERARAGAVAN, sir.
Morning, good morning.
Very good morning, sir.
Yeah,
Yes, sir. Sir, can we wait for a few minutes, sir? For 10 minutes?
sure.
People are
Still
joining.
another 10 minutes are there. Time is there.
Yeah, sir.
Yeah.
Thank you, sir.
Sir, good morning, sir.
Morning.
Very good morning, sir.
Yeah.
I am at the home, but my mother's ceremony puja is there, so I am muting my camera, sir. Like I am sitting there,
Okay, no
and,
problem.
yeah. Another
Yeah.
one of the puja is. So
Okay.
let us wait for some time, sir. Participant will come because 10 minutes is there. We'll wait, sir.
Yeah, yeah.
Please.
Fine. No issues. Yeah.
Thanks a lot, sir.
Yeah.
Thanks. In between, I will share links to some of the contacts so that
Ah,
I will just remind them. A gentle reminder,
yeah.
I'll give them.
Right.
Thank you,
Yeah.
sir. Thanks. Yeah,
Right.
thank you.
Yeah. Sivraj, you're from where?
Sir,
Sivraj? Yeah, I will
yes, sir.
thank you. Yeah. You're
Sir,
from
I
the
am one of
college or
the.
from where? Where are you working?
Actually, I am working for Dr. Rajan, sir.
Okay, fine. Okay.
Uh,
Yeah. This Mancha Swami?
sir, she is one of the participants, sir.
Correct. But where is she working? Is she a teacher or a consultant or what? That's
I
what I'm
don't
trying to
know
find
that,
out.
sir. I will check and tell you, sir.
No. She's there. She's already logged in.
Uh,
I wanted to see
uh,
whether she's active. Yeah.
Sir, are you going to start? I think you can start, sir. People will joining. Time is up. Shobana,
Okay, sir. Okay, fine, sir.
I think people are joining. I have shared to everybody, so people are joining. They're taking 5 to 10 minutes.
Okay,
Like
sir.
so many groups I have shared, so people are responding. They'll join in soon.
Okay, sir.
Yeah, I
Um,
think, but because sir will be having other work, so let him start.
okay, sir. So good morning to
Thank
one
you,
and all
sir.
present here.
Yeah.
So welcome you all for the day 6 of SVTP Phase 2 program. So let us start the first session of the day 6. So welcome Dr. A. VEERARAGAVAN, sir, a professor at Department of Civil Engineering from IIT Madras. He's going to deliver his lecture on long-lasting highway payment issue and challenges.
Is the screen visible?
Yes, sir. Visible, sir. Clearly.
A very good morning to all the participants of this short-term training program. The talk today, what I will be making will be on long-lasting highway payments. What are the issues and concerns? I'm sure that some of you would have attended the first course STTP organized by Dr. Rajan, wherein you have studied extensively about the different binders, mixers, characterization, etc. In this program, little more advanced about the construction you have seen. So what I'm going to talk is mainly about the construction of the highway payments, what are the issues and what are the concerns. So you know pretty well that you design a payment. Number 2, the payment is also a civil engineering structure which needs design. But according to me, the pavement is one of the complicated civil engineering structures because of several uncertainties. Uncertainties in the material, behavior, and its characterization. Maybe binder, maybe cement, maybe lime, whatever it is, soil. Maybe problem of uncertainty in the mix and the design. Climatic factors, traffic variability, environmental conditions, and most importantly, construction quality. So the question arises at this point of time, if you design a pavement by characterizing the material in the laboratory, will it work in the field as predicted by your models or not? What is the probability that it will last in the field as designed? For example, pavements are designed for 15 to 20 years, which means for 20 years or 15 years, you should not warrant major rehabilitation. Can the bituminous pavement last more than 20 years? Is one question that you have to answer. What do you mean by long-lasting pavement? How long is long? Whereas a bituminous pavement is generally designed for 15 to 20 years, a concrete pavement is designed for nearly 30 years. The question which I pose now is that, can a bituminous pavement last for 30 years, 40 years, 50 years? Is it possible? These are again the issues and concerns that we will be talking about. What do you mean by the long-lasting pavement? A long-lasting pavement is a type of pavement where no significant deterioration will develop in the foundations or the road base layers, provided that correct surface maintenance is carried out. So you understand few points from this one slide. A long-lasting pavement requires a strong foundation. It requires good base. So what I want to tell at this point of time is that, don't think that I use a better binder or a modified binder or a crumb rubber modified binder, my pavement will last long, unless you take care of the subgrade and the supporting layers. More importantly, according to me, the two major factors that influence the performance or the life of the pavement are subgrade and its compaction, subsurface drainage. If you can take care of these two parameters, I'm sure that many of the pavements will last longer. So for a long-lasting pavement, you require a strong or a better foundation. So you should also think in terms of the benefits. What are the benefits of having a strong foundation? The benefits of a strong foundation are improved performance. Life is more, thickness is less, cost of construction is low. Therefore, the maintenance cost is also low. So, simplest way by which one can have a long-lasting pavement is by improving the strength of the supporting layers. I don't say subgrade, I'm saying supporting layers. It can be base, it can be subbase, it can be subgrade. It may be the soil beneath the subgrade, the supporting layer, maybe an embankment. All parameters matter. So, what you think is that you go to a quarry, bring the materials, test the materials in, in the laboratory, and then you presume that will be the soil from the pavement till the center of the earth. No, the supporting soil layers play a very important role. That is why we brought in the concept of effective CBR. The soil beneath the 500 millimeter subgrade will also matter. For example, if H is the height of an embankment, 3 meters, 5 meters, then you should investigate the soil properties at least 2H. If 5 meters means 10 meters beneath the soil and its properties, you should study, investigate, and take care of them. But majority of the PhD work that you consider, they'll consider one soil, bring it to the laboratory, test it, model it, publish it, get a degree. But that cannot be translated to the ground in reality because of the variability in the materials, even with the depth of the layer. The second is that the surface maintenance is another issue. Even though you design a pavement for 15 to 20 years, this pavement will warrant maintenance. It's just like a human body. You'll fall sick. You have to go to a doctor. You cannot say that for 100 years where I'm living or 60 years I'm living, I will remain without seeing a doctor. It requires maintenance because of wear and tear, because of many factors, construction quality variability, uncertainty in the traffic, many factors influence the performance, and therefore maintenance is also required. So if you want a long-lasting pavement, have a strong subgrade, have a strong base course, have a good subsurface drainage, have an appropriate designed, well-designed surface bituminous layers. That's all you need at the end of the day. What does it mean? So deterioration of the pavement is confined only to the top-down cracking and the deformation in the bituminous layer. So the possibility is that we expect the maintenance requirement may be only due to top-down cracking, because the bottom-up cracking is expected to occur at the end of the life. So when I have a long-lasting pavement, 15 years, 20 years, 30 years, I design in such a way that the fatigue cracking does not occur at the end of the design life, before the end of the design life. So the pavement is sufficiently strong for the anticipated traffic and it's well built. Quality of the construction is good. The construction finally translates the design into a reality. So that's why I always ask these people who test materials in the laboratory, then model the material in the computer without coming to the field. Unless the design is translated exactly as you have tested in the laboratory, the performance will be entirely different from what you have done in the laboratory. So therefore, what I found is that it is not the mathematical model and its flaw that fails the performance prediction. What fails is the quality of the construction. Quality of construction, starting from materials, mixes, and compaction, density, voids, many factors come into picture. So quality of construction mainly influences the performance of the pavement. So the aim of a long-lasting pavement program should be, you have to determine what is the best. Best in the sense, a design which will result in the lowest virgin aggregate consumption. That's why I will call it the best. Not only initial construction, for a period of 15 to 20 years, you should not warrant major maintenance. And the design should be optimal, such that the quantity of aggregate consumption, binder consumption is also the lowest. It should be optimal. So you have to now decide the payment type based on the life cycle cost. Normally, what we do in the Indian context is that whoever quotes lowest L1, the work is awarded to that agency. But that design, which results in the lowest cost, need not be the one that lasts longer, need not be the one that warrant less maintenance. Therefore, you should now design a payment and award the project to a contractor who has quoted the lowest life cycle cost. That means you as a client should be capable or knowledgeable to evaluate alternate designs. 10 bidders, 10 contractors may submit 10 bids, 10 designs. You have to find out which design will result in a longer life, optimal thickness, optimal design, and improved excellent performance. So this is the challenge that we will face in the years to come, more importantly, when aggregates are not available. Many of the states have banned quarrying. When the quarrying has been banned, how do you construct the pavement as per the design? You assume some CBR value, you assume some traffic, you design the thickness. Thickness comes to say 800 millimeter, 900 millimeter, 1 meter. But when you go to site, after the work is awarded, you'll find that the aggregates are not available. Soil as per the design is not available. You're sitting in a computer room, you can design any CPR. You can design any pavement. But in reality, you can imagine for a 6-kilometer road of formation width of at least 25 meters formation width and 1:3 embankment for at least 5 kilometers, 100 kilometers, you work out the quantity of material that is required. Several lakh cubic meter of soil alone will be required. What is that you do in the laboratory? Bring 2 kg, 3 kg, 5 kg, test them, mix it OMC by hand, compact it, find the density, and then expect the pavement to be compacted at OMC to the maximum dry density as you got in the field. Never it is achievable in the field. Therefore, there is always a shift between the laboratory determined life and the field performance. So this again I had mentioned in the last class. There are different layers of the pavement. What we expect is the rutting is due to the vertical compressive strain on top of the subgrade. That's what my assumption. I design the pavement based on this assumption. I do not consider the rutting within the bituminous mix. That's another flaw. Number 2, I expect the cracking in the pavement to occur only from the bottom. And when the excessive tensile strain at the bottom of the bituminous layer causes a cracking at the top. So these are the 2 basic principles on which the thickness is determined. But what it does not consider is that there can be top-down cracking because of the tensile strain developing here. Do you account it in the design? No. Why? Because it is not a structural parameter. How do you account it? Why it occurs? These occur because of overloading, higher tire pressure, aging of the bitumen, and many, many other factors. Therefore, the design, according to me, means not only structural design, it should also guarantee me the functional performance. Functional performance in the sense, rutting, surface cracking, traveling, potholes, all they should be addressed. That is why I say appropriate selection of the bituminous layers. Second, the bituminous layer again consists of 2 different layers. The top layer is different from the bottom layer. You look at the researchers, what they do. They consider the bituminous concrete. Bituminous concrete, they may do a particular gradation or vary the gradation, consider 1 binder content or at optimum binder content, and then test the material. But the top layer should be a rut resisting layer. The bottom layer should be a crack resisting layer. So how do you ensure that the layers are rut resistance? How do you ensure the layer is crack resistance? This is another question. So you understand at this point of time that top layer has got a different mix gradation, different binder content. The bottom bituminous layer has got a different gradation and a different binder content. We call in one flower bracket HMA, hot mix asphalt. But since the functions are different, or the purpose of laying them is different, the distresses are different, both are to be differently designed. It again means one design, one mix will not cater to both rutting and cracking. Therefore, now countries are exploring a balanced mix design, which will balance both the distresses of rutting and cracking. Is it possible? Maybe possible, but we are expecting some results as how one mix can take care of both rutting as well as cracking. The one more point that you should consider here is that this base course I am providing it as a granular layer. I can have again different options. Can I have for a long lasting pavement, what should be the base? If you remember, I just now told a strong subgrade and a strong base. Can I have a cement treated base? Yes, you can have. Can I have a bitumen stabilized base? Yes, you can have. Now there are three options. One is a granular base. One is a cement treated base. The third is a bitumen stabilized material or a BSM. IRC calls this RBM, reclaimed bituminous materials. Whatever it is. There are three bases: granular, cementitious, and bituminous. So for a long-lasting pavement, will a granular base a better solution? Or in other words, will a cement-treated base result in improved performance? Most probably. Can a bitumen-bound base perform better? Again, maybe most probably yes. How to do that? So that means for a long-lasting pavement, one has to explore different bituminous layers, different materials, different gradation, different binders, different binder contents, different base courses, different subbases, and different subgrades. Different subgrade in the sense stabilized subgrade. It can have any type of stabilization. There are a number of stabilizers available, commercially available stabilizers are available. I can give you a design using a chemical stabilizer. Sorry, I don't call it as a chemical stabilizer. They say that it is not a chemical stabilizer. They say it's a natural stabilizer, which can be mixed with the soil and cement. Soil, cement, and the stabilizer. That's it. No aggregates. No aggregates. I can give you a design for a pavement which can last for 30 years. Do you believe? Yes, they are available today. I think view from the conventional method of research that you have been doing, I think you have to now switch over to the other side. Keep your eyes and ears open. Look at what are the new materials, designs available. I feel again, civil engineering, we have to move away from the conventional brick, stone, cement, soil. I think we have to come out with the new materials. I think interdisciplinary research is what is required today. What I mean is that we should work with the chemistry department, chemical engineers, and other department colleagues in your own institution and come out with the new binders, make in India binders, which will result in reduced thickness of layers, reduced cost of construction, and improved performance, or in a nutshell, a long-lasting pavement. So in the case of pavement design concept, what we normally, if you want to have a long-lasting pavement, you should have a high modulus rut-resistant material. It should be a rut-resistant material. So this is a 4 to 6 inches, 10 to 15 centimeter is the high compression. Therefore, it should resist the rutting. The bottom layer should take care of the maximum tensile strength. So it should be a flexible fatigue resisting material. So it is not a stiff material, it's a flexible fatigue resisting material. How to make it? Simple. You can increase the binder content by 0.5%. Then you can look at the fatigue life. Fatigue life may be more. So one way of doing that, can I use a modified binder? Yes. Will the modified binder result in a higher modulus? Maybe. If I have a higher modulus, can I reduce thickness? That becomes the question. So we have to now think whether modulus is the indicator for an improved performance. That is where the entire system of payment design revolves. What you presume is that higher modulus, better performance. Maybe, may not be. So higher strength does not mean improved performance. There are many factors come into picture. So, but at this point of time, remember, a high modulus rust-resisting material is required at the surface course. That may or may not give you adequate skid resistance. Therefore, an open graded friction course of 1.5 to 3 inches stone matrix asphalt or a super pave mix is required. So, what is important is a good skid resistance, a good rust resisting mix. Therefore, you have to consider alternate designs of materials and mixes for a long-lasting pavement. When you talk about a fatigue-resisting asphalt base, what you're trying to do is that you have to minimize the tensile strain at the bottom of the bituminous layer with adequate pavement thickness. I want to reduce the strain. What can I do? Increase the binder content. One solution. Improve thickness. Strain values are lower. But increasing thickness means you need more quantity of material. You're increasing the cost. So therefore, you have to now balance. That's why I said optimal design. Optimal design does not mean lower strain only, but at the same time with a reduced thickness. Thicker or stronger pavement, lesser is the strain. If you can keep the strain values within the allowable limits, you'll find that it can take infinite number of fatigue repetitions. It's possible by a high asphalt content, use of modified binders, we have to now design. So I am always for working backwards. What we do today is that I test a binder, I characterize the binder. I test the mix, I characterize the mix. I use these mix properties and the binder properties in the pavement design for a given traffic. And I expect the pavement to perform as per my design. But my question is different. The condition of the pavement at the site may warrant a different design. So I want an improved performance. The question arises, what is the performance that you need? Is only fatigue cracking and rutting or something else? Yes, I need more. Both structural as well as functional performance I need in the field. If you want that performance, what should be the design? What should be the mix? What should be the binder? I think the research in future should be backward from performance to the required binder rather than from binder to performance, as you predict. I think once you do this reverse engineering, then there's a lot of potential for research. Finally, proof of the pudding is in the eating. I need a good performance. When I know that the material that I test in the laboratory may be or may not be the one which I'm using in the field. Therefore, what you should do is that from the field course, find the modulus. That's what I'm telling. Don't expect compact them perfectly in the laboratory. Find some number, use that in the design and find out thickness. Go to the field, take 10 cores, 20 cores, 30 cores, test them. Check whether they are getting the modulus as you designed. If not, adopt that modulus. Again, statistics have to come into picture. So a pavement consists of different layers, starting from the embankment, subgrade, subbase, base course, and the blacktop. The blacktop, which is maybe around 200 millimeter, costs nearly 40% of the total pavement cost. Therefore, if you want to reduce the cost of construction, simplest solution is reduce the thickness of the bituminous layers. How should you do that? You can do that by improving the strength of the lower layers. Simple. Lower layers are cheaper. For example, a subgrade soil may cost few hundred rupees, 200, 300, 400 rupees, 500 rupees per cubic meter. Subbase may cost 1,000 rupees, 1,500 rupees per cubic meter. Base course may cost 1,500 to 2,000 rupees per cubic meter. But the blacktop costs 8,000 to 12,000 rupees per cubic meter. So if you want to reduce the cost of construction, reduce the thickness of bituminous layer by improving the lower layers or the supporting layers. So how to extend the life of pavement? How to prevent the failure is something that you should answer. Simple, as I was mentioning, is improve the compaction. So if you, for a given soil, that's again relating theory of the lab to the field. In the lab, you do compaction. You use a Proctor compaction, either IS light or IS heavy. How is it related to the field compaction by a steel wheeled roller? That is 10 tons, 12 tons. Whereas you are testing it at 2 kg, 1 kg hammers. Will that reflect that? May not be. Will you be able to get a higher density than the laboratory density in the field? Yes, it's possible. Because modern compaction machinery are capable of compacting to a density much higher than your laboratory density. Your lab molds, rammers which you are using, are less than maybe 2 or 3 kgs. But there it is 10 to 12 kg, 10 to 12 tons. So by improving the compaction, you can reduce the compressibility, reduce subsequent changes in volume because of the variations in the moisture. Erosion is reduced, life extends. Thereby, it warrants less maintenance and hence lower life cycle cost. So simplest solution which I can think of is improve the compaction. What normally we do is that we used to compact a soil layer or an aggregate layer for about a meter, 50 centimeter, 30 centimeter in one layer. When you compact this 30 centimeter in one layer, you'll always find voids. The roller which compacts here will not be able to ensure that the fines fill these voids and make them dense. So the static roller of 10 tons may not be able to compact well. On the other hand, if I use a vibratory roller, then I will be able to compact to a much, much denser mass. As I have been repeatedly telling, higher density means lesser voids, means improved performance. This again means lower thickness of the layer. For example, if you are getting a CBR, say for example 6% CBR, 7% CBR at IS light compaction, change over to IS heavy compaction. See, this 6 will become 8 or 9. This 7 will become 9 or 10. Then you will find that the thickness requirement of the pavement layer will be lesser. Simple. I am not doing anything. The same soil, I am compacting to a higher density. Similarly, use of appropriate rollers in the field will guarantee you improved compaction, improved density, improved strength, and hence improved performance. So in case of vibratory roller, two factors come to picture. One is the amplitude, where the wheel goes up and down. Other is frequency, number of times the load is applied on the surface. One can be a low frequency, other can be high frequency. So if you want to have an improved compaction, improved density, improved performance, this is something that you should look for. Depending upon the type of material that you are using, you have to choose the appropriate amplitude and the frequency. So you'll find that for a sand and a gravel, the desired recommended amplitude is 0.8 to 1.2 millimeter. And the frequency is order of around 1600 to 2000 cycles per minute. Whereas when the vibrator roller is used to compact bituminous layers, the amplitude should be 0.4 to 0.6. The frequency should be 2500 to 3500. As a thumb rule, it is high amplitude, low frequency for soils. It is high frequency and low amplitude for the bituminous layers. So if you do ulta, it will not be able to compact as you want. But you should know what are the ranges of amplitude, what are the ranges of frequency. Construct a test track, test section, 30 meters long, 3.75 meter wide. Check the density after 3 passes, 5 passes, 8 passes with a field density test. And then if the density is achieved, then you decide the number of passes that is required. Now, the number of nuclear and non-nuclear density gauges have come. Instead of taking a sand pouring apparatus, you'll be able to test hundreds of points in a day. Within a minute, you'll get the density of compaction. You can decide the depth of the layer for which you want to check the density. And you can, but it needs calibration. Once you calibrate, I'll be able to do several hundred tests in a day. So I think after you use a calibrated density, this will ensure density is approximately uniform along the length of the road as well as across the width. Because of this variation in the density only, you'll find at some location there's a pothole. 10 meters down, there is no pothole. Same soil, same roller. Why? Compaction is more in one places, compaction is less in other places. If you can use such density gauges, you will ensure that the density of compaction is uniform along the length of the road as well as across the width of the road. Pass. Each time a roller passes, it is called as road entire area, it is called as a pass. How many passes are required to achieve the required amount of compaction? A roller goes up and down, overlaps by 1/3, overlaps by 1/3, 3. Then from the other end, 4, 5, and 6. So this entire sequence of 6 operations constitute one roller pass, not 6 passes, one roller pass. Like this, 6 passes may be required, 8 passes may be required. This layer 1 provides a confinement to layer 2. 1 and 2 provide a confinement to layer 3. That's why 1, 2, 3, 4, 5, 6. This constitutes a single pass. But you'll find that if I use a vibrated roller, 6 passes, or a static roller with the 12 passes, think at a thickness of 250 millimeter compacted layer. So you'll find that if the thickness of the left is 250, I will be able to achieve only 97.5 is the density modified proctor that I can achieve. Whereas with 6 passes of a vibrated roller, I'll be able to achieve more than 100% of the laboratory density. So right amplitude, right frequency, right weight of the roller. Depending upon soil type, you should be able to find out what density is achievable. A soil that is compacted to high density will perform better. But as the number of passes increases, the density keeps on increasing, but it will reach a particular value beyond which the soils will say, no, I cannot be compacted further. Then the density will fall down. Its surface will develop cracks. Water will get in. Therefore, you have to establish a rolling pattern, find out the maximum number of passes that are required to achieve the density in the field, maximum density that is achievable in the field. So once you achieve a higher density, rutting will be lower, fatigue life will be higher, structural strength will be more, permeability is low, raveling will be less. So the simplest measure for a long-lasting pavement is to improve the compaction standards, improve the density of compaction of the soil as well as the embankment layers. Second, drainage. Drainage, this always said that there are 3 causes for a poor performance of a pavement. 1 is drainage, 2 is drainage, 3 is drainage. Especially for a civil engineer, I always tell the water will never pardon you. If you don't give it the respect it deserves, it will always remain. Whether it's a case of a roof slab or it's a case of a pavement. In a roof slab, it will drip down on your head, saying that you never cared while you are casting the slab. I'm here. Similarly, the pavement, it will form a pothole and it will remain there. So design of drainage system is a key element for the design of the pavement systems. The performance directly depends upon the quality of the drainage. If you are able to drain off the water in the quickest possible time, your pavement will last longer. Otherwise, even if you put a steel plate, it will not work. So currently in India, we consider granular subbase. Of late, we are using cement treated subbase also. The gradation and the binder properties, material properties play an important role. If you don't ensure adequate drainage, water gets entrapped in the pavement system. So you should study what is the influence of surface drainage on the performance. So if you look at the IRC gradations, there are 6 gradations that they have given. The water can get into the pavement through the shoulders, earthen shoulders. That can be seepage from the high ground level. There's a rising water table, there will be capillary action. Through the potholes and cracks, water will get in. This will saturate the subgrade. saturate the base course, saturate the subbase. And the load carrying capacity of the pavement system is lower. It will weaken the pavement layers, it will degrade the material, and it also ensures that there will be a lack of bond between the bituminous layer and the granular layer. But all these three occur simultaneously. But this damage will occur only in the post-monsoon period. For example, in Tamil Nadu, now December, January, subgrade is saturated. Heavy overloading, more rutting will occur, more failures will occur, shear deformation will occur. So more damages will occur when weakened pavement is subjected to heavy axle loads. Post-harvest season, trucks are overloaded, subgrade is saturated. With the result, there will be more rutting and shear deformation that is likely to occur. So in the case of bituminous layer, water will strip off the binder. When with hydrostatic pressure, they try to strip off the aggregates, the bitumen, and you will find that a bituminous layer will look like a granular layer. So you'll find there are 6 gradations IRC has given. If you look at the permeability of all this, we require 300 meters per day of permeability. If 300 meters of permeability is not there, the pavement cannot perform. So out of these 6 gradations, which one to be adopted? What is the permeability of each of these gradations? You find that the major factor influencing the permeability is the fines. Fines in the sense passing through 75 micron. In the fines earlier, we had permitted up to 10%. And we found that the causes for the failure is fines, too much of fines. Now we have reduced the fines to less than 5%. If you look at the permeability, vertical permeability, you'll find grading 3 and 4 meet the requirements of 300 meters per day. Even look at the horizontal permeability, they meet the requirements. So of all the 6 gradations that you are having in IRC or the ministry specification, grading 3 and grading 4 will meet the requirements of permeability. So even though 6 gradations are given, you adopt either grading 3 or 4, and you should extend for the full formation width. Only then the water will be able to let off from the pavement to the drains. Bituminous layers. The bituminous layer should offer, first we saw about the subgrade and its compaction. Second, we saw about the subsurface and its importance. Third, bituminous layers. You should offer a high resistance to deformation, resistance to fatigue. It should reduce the stresses at the bottom layers. It should not undergo environmental degradation. It should be impervious as much as possible. Good workability so that I am able to achieve the required density and the voids. Sufficient texture so that there are no skidding accidents. And I should be able to predict the performance of the pavement. So now, by now, you would understand there is nothing like a one-size-fits-all design. Different types of surface courses are there. So we have different specifications. Some are good, some are bad. The specification does not tell use this or use that. It is for the engineer to decide. Bituminous macadam is one open-graded, highly permeable recipe mix, no mix design. It's only the gradation, binder content. Strength is 50% of the dense bituminous macadam, and it is not cheaper than DBM. So if you want to use a bituminous macadam like this, there's a lot of voids here. So it will entrap the water. It will not allow the water to go out. With the result, the pavement will prematurely strip off, either grading 1 or grading 2. Both are permeable. Therefore, for long-lasting pavements, do not adopt such pervious mixes. That's a simple lesson. When you have a poorly graded mix, you find it's not dense. Take a glass of water and pour on this. Entire water will get into this. So the bottom line for a long-lasting pavement is not to adopt such pervious bituminous layers. There are different gradations given in IRC, DBM, SDBC, and the DC. The thicknesses are also given. I want you to look at one parameter. One parameter is the nominal maximum aggregate size. Nominal maximum aggregate size is the size in which some aggregates are retained. So whatever that is retained, that is 90 to 100, 26.5. NMIS is 26.5. 90 to 100, 13.2, 13.2. So nominal maximum aggregate size is the largest sieve in which aggregates are retained. There's also another philosophy which says 10% of the aggregate is retained, but in India, we adopt any sieve size in which 10% material is retained is considered to be nominal maximum aggregate size. Second, if H is the thickness of a given layer, the maximum size of the aggregates or the nominal maximum aggregate size should be 1/3 to 1/4 the layer thickness, which means if 100 millimeter is the thickness of one bituminous layer, maximum size aggregate can be 26.5 and down. So you now look at it. Now, based on this definition, you look here. That's 7.5. Is the nominal maximum aggregate size? My layer thickness is 75. So in 75 millimeter, there are only two aggregates, but the layer should be dense, impermeable, and lasting longer. But I have only two aggregates in a given layer, so voids will be more. Therefore, do not adopt DBM grade 1. So look at grading 2. Okay, 75, 26.5, at least 3 aggregates are there. Therefore, you should ensure that the nominal maximum aggregate size that you choose should be 1/3 to 1/4 the layer thickness. Second, as the aggregate size becomes smaller and smaller, binder content will become more and more. It's worth because it makes more dense. So if you come from DBM to SDBC to BC, you'll find binder content changes from 4 to 4.5, 4.5 to 5, 5.2 to 5.4. So smaller and smaller aggregate size, 19 millimeter, 13.2 millimeter, more surface area, and hence more binder content. DBM is closely graded, is used as a binder course, not as a wearing course. So this DBM can be 37.5 and 26.5 as we just now saw. The percentage positive to 4.75 remain the same. Problem is that only a marginal gain because binder content is 0.5% lesser, but there is a lot of segregation, high permeability, and hence not recommended. So if you want to have 75 millimeter thick binder course, have grading 1 only. If you have 150 millimeter, have 2 layers of grading 2, not 1 layer of grading 1 and 1 layer of grading 2. So you'll find a lot of segregation, water will enter into the paper. There's also a relation between the voids and the permeability. We'll find that when it is 25 millimeter, even 5-6% voids will have a higher permeability. We want an impermeable mix. Therefore, apart from the aggregate gradation, binder content, the density of compaction also plays an important role. If you take a core of a DBM specimen and check, you'll find DBM there is no binder at all because grading 1 allows the water more and it strips off. So you'll find the stripping of the DBM layer. Therefore, in lieu of grading 1, adopt grading 2. There will also be shear deformation. BC is not a layer. This is from Topurghat, where the accident occurred maybe last week. So again, there's a lot of rutting there. Shear deformation. Why? BC mix is not capable of taking the shear deformation. There will also be rutting along the wheel path, again because of the poor dense bituminous mechanics. This again the same section, rutting and shoving. Again, a poor mix gradation. There can also be a case where the bituminous surface course remains intact. By the binder course, it expands and it shears off and results in the rutting. So you'll find that the voids in the mix is very high, it will crack. If it's very low, it will bleed. It's not a crack, but it will bleed. So now I have to strike a balance between cracking and the rutting. The layer will undergo densification. Voids will decrease with the passage of traffic. So what should the voids initially? What we found is that when you open the road to traffic, if the initial void is around 7%, this 7 will come to 6, 5, 4, and will stop at 4. Therefore, the maximum density to which I should compact theoretical maximum density should be only 93% of the maximum dry density. There should be 7% voids initially. In the case of high voids, you'll find that the air voids after trafficking is less than 4. There is a lot of rutting. with around 4, you'll find the rutting is much, much lower. So compact to the required density. Compaction, a 1.5% increase in the density leads to 10% increase in the fatigue life. Therefore, if you do not compact it to high request density, your pavement will prematurely fail. So I showed about the shear deformation. What is the solution now? The solution is a stone mastic asphalt or stone matrix asphalt. Anything, there are different terminologies. So this is a rut resisting mix, gap grader mix. It consists of aggregates, asphalt-rich mortar, mineral filler, and cellulose fibers. So because of, if you adopt this, you'll find the rutting, SMA grade 1 and grade 2, no rutting, no shear deformation. So if the traffic is very heavy and you want to have a long-lasting pavement, in lieu of the bituminous concrete, adopt stone matrix asphalt. So this stone matrix asphalt will last longer without without any rutting. Thin layers, when you come, premix carpet we adopt. You'll find a lot of potholes occurring on the surface. There's no seal coat. Water will be permeated in less than 5 seconds. If you have a moderate seal coat, it will percolate in 90 seconds. If you have a heavy seal coat, still water will get in. The lesson learned, premix carpet is not the surface course to be adopted. It is permeable. You have a bituminous concrete surface, water will not permeate. Mixed design is there, high binder content. So even for rural roads, you should not adopt this open graded premix carpet. There are different technologies, either surface dressing you adopt or go in for a dense mixes. So there are different gradation mixes adopted in India. The simplest mix that I can adopt can be dense bituminous macadam grade 2, bituminous concrete grading 1 or grading 2, or a stone matrix asphalt. If you adopt any of this, definitely most of the pavements in India will last longer. There are cases of premature failure. This is a case of a highway in India, 240 kilometers, constructors spending 2,400 crores. The pavements start failing in 3 months after opening to traffic. The same section, I'll show you the same section. I'm not showing a different section. Same highway, it has failed. You'll find cracks in 3 months. It was open to traffic in July, August, September I went. These are the cracks, photographs I took, potholes, cracks. Rutting, you'll find rutting also. Again, stripping, shear failures, all the stresses you talk anything. But what went wrong? If you look at the compaction was inadequate. Because the stability was inadequate. Binder content was low. In the case of a BC, in the case of dense bituminous macadam, air voids, compaction. So again, it results in a poor performance, even though the binder content was okay, but compaction density plays an important role. So on paper, your mix is good, but when you translate the mix into a reality, you miserably fail. So from the forensic investigation, we found that a material which is compacted to higher densities, say 96.2, compact subgrade to 97, 98, no distress. When they're compacted to 92%, subgrade to 97 only, you'll find the shoving, alligator cracking, raveling, and potholes. So poor quality construction will reduce the life of the pavement significantly. Preventive maintenance is something that we should be able to do it. So if you do a preventive maintenance for a long-lasting pavement, you'll find the life of the pavement will extend. What are those treatments that can be done? The treatments that can be done can be, you can also quantify the benefits. Supposing if we do a treatment here, assume that this shaded area is the benefit. I do a treatment here, cost is lesser, but it will extend the life of the pavement. So what is needed for a long-lasting pavement in India is to go in for preventive maintenance. Compare the preventive maintenance with rehabilitation, the benefit cost ratio, you'll find that the benefit cost ratio of a preventive maintenance is much, much higher than a conventional rehabilitation. Yet stitch in time will save 9. There are different treatments available: Fox seal, slurry seal, microsurfacing, chip seal, thin overlays. Any of this can be adopted. They are cheaper, but will extend the life of the pavement, will guarantee you an improved performance. Fox seal is an application of diluted slow setting emulsion, which will prevent the aging or hardening of the binder. Slurry seal is a mixture of fine aggregate, filler, and emulsion, again a cold mix. This will improve the friction. It will also ensure that raveling is taken care of. Therefore, a cheaper treatment, less than 100 rupees, 150 rupees per square meter. You can also go in for a case of, I think, the other treatments, I don't know why it is struck here. Other treatments which can be thought of can be a case of a microsurfacing, which can also be adopted. So this microsurfacing, when adopted, may be costing less than 200 rupees per square meter, will guarantee you a satisfactory performance. So therefore, I think that's a problem with the slides. So what I want to conclude is that a good compaction will guarantee you a satisfactory performance. A good subsurface drainage will guarantee you a satisfactory performance. Yeah, let me try again if I can share the screen. A good compaction, good subsurface drainage, good bituminous, right choice of bituminous mixes and the layers, and the timely preventive maintenance will guarantee you a long-lasting pavements. So when you design the pavement for a given design life, when materials are not available, then ideally what you should resort to is mainly you should resort to recycling. So reduce, reuse, recycle will be the mantra that you have to adopt in the years to come. By adopting this recycling method, you will be able to save large quantity of materials. So you have to choose the appropriate recycling method to guarantee a long-lasting pavement. I think I'll close with that. There is a problem with my presentation. Anyhow, I shared the presentation. If you have any doubts, you can ask me. So I am happy to answer any of your questions at this point of time.
Thank you, sir.
Yes.
So participant, do you have any question? You can directly unmute your mic and can directly ask to sir, or even you can post your question in a chat box.
Any questions?
Sir, I think a question from Anne George, the first question. Can you able to see, sir, in chat box?
Yeah, how can we improve the life of pervious mixes, I think.
Yes, sir, life of pervious mixes.
Yeah. I don't know why there's a problem with my presentation. Yeah. So pervious mixes, I have one question to Rajesh Shagar. Okay, Prashikar Rangaleska. Okay. The issue is that pervious mixes are definitely better because they will let off the water, but the issue will be, only issue will be the clogging of the pores. So you, so long as if you're in Indian context, that will be the challenge. So you have to remove or clear them with a water jet, and that is the only solution by which you can extend the life of a pervious mix. Rajshekhar has got another question.
I think he's proceeding with the question, sir.
Okay,
After
porous
that,
asphalt,
previous solution.
okay, porous asphalt pavements are also designing for long life. As you said, bituminous macadam will not be porous. Yes, right. But you should remember, this porous mix which I am talking is not a structural layer. You design the pavement with the bituminous mixes which I have listed so far as a structural layers. But this open grader friction course is a functional layer, mainly to enable permeability. Secondly, to improve the friction. So definitely none of the pervious courses will last for 15 years or 20 years. They will get clogged, they will get crumble. All these are possible. But you can mill the layer and relay it again, the top layer. that does not mean it will not last longer. So pervious layers can definitely improve the friction, improve the permeability, and enhance the life of the pavement. Rajshekar, we have any existing old data of asphalt deterioration of the data collected for the last 2 years? We do have some data on some of the sections that we have constructed in Karnataka, NH 207. Deflection, I think distresses are available. Maybe I will be able to share the data. To avoid segregation, we need to use a well-graded aggregation. Well-graded, the issue is, I do agree, one part is that well-graded mix. But generally, the major flaw is that in the laboratory, you do a particular, take about 1.2 kg, mix it in the lab, compacted well. But when you do 200 tons per hour, 300 tons per hour, and many times, if they are not well mixed and compacted, there will be a segregation. Sometimes the fines will be lesser because of segregation. It's not problem with the gradation. Problem is with the mixing. Problem is with the laying. That will result in segregation. So one, as you rightly mentioned, is due to gradation. Number two, due to the construction because of segregation of the mixes at the site. Rajshekar, what is the view on the open graded friction course provided over the BC? I think I fully agree with that. Now that with the high-speed highways being constructed, expressways being constructed, Nagpur-Pune highway at 150 kilometers per hour design speed is constructed, we need more open graded friction courses. At the order of the day will be a functional layer to improve the friction. We have now just finalized yesterday a IRC code of practice on friction, how to measure the friction, which equipment to use, and what should be the desirable value. I think once the code is in place, we will address the issue of skid resistance, and definitely OGFC will be the solution in the long run. Any other questions? The Times of India published the pothole skill. Okay, there is one question from Patel across India, which while terror correct. Definitely, see, this is a pothole. Is right. I cannot pardon an engineer who does not fill a pothole. The routine maintenance, which is expected to be done day in and day out, is filling of the potholes, sealing of the cracks, dressing the shoulders, as well as drain desilting. If it is not done, it is a fault of the engineer concerned. In the case of railways, you just compare the other side. A simple fish plate, if it is removed, all the fellows, all the officers up to the chief engineer, everybody will be pulled up. But in roads, nobody is accountable, nobody is responsible. So this pothole definitely kills. But I think it's time the public are aware of the flaw in the system and sue the public works department for not providing a pothole-free road. Then they will be answerable, they'll be alert. Similar to the case of skid resistance, which Rajshekar is asking. I think that I wanted to stop the vehicle before hitting a pedestrian who was crossing the road. I apply the brake. My tires are good. My vehicle condition is good. But still, I could not stop the vehicle before hitting the pedestrian because the skid resistance was low. Again, a flaw with the PWD. So you saw the PWD. Why are you not providing a road with adequate friction? Then they will become alert. I think the creation of an awareness among the road users about their right to have a good accident-prone or a defect-free road should be managed, and that is where there's a flaw in the system as on today. So Rajshekar is doing ME thesis work on OGFC permeability and clogging behavior. Sir, is there any section in India where OGFC is already done so that I can collect the field data? I think the OGFC has been conducted somewhere in the north. I am not sure about the exact changes, but I do not know. You can talk to Krishna Beligiri at IIT Tirupati because he is working on pervious concrete. I do not know whether he has got any sections to compare his pervious concrete with the OGFC. He may be able to tell. But I know that some trial sections have been constructed. The reason as why it was not adopted all these years was that there is no code of practice. Today, IRC last year, 2019, they have published a new code of practice on OGFC. I think once that is constructed in a large scale, then definitely you will have more test sections. And as I was mentioning, the Nagpur-Pune expressway with a speed of 150 kilometers per hour design speed is constructed, it should definitely be provided with an OGFC. I think you may have test sections, but I am not sure where it has been laid. I may have to get some details. If I get some details, I'll pass it on to you. Any other question? Kishore, will it be a good method concentrating? I think Kishore has asked. Good method concentrating the conservation of rainwater in side drain portion, then allow the water to percolate through the structure and to make it weak. No, there's a misconception here. The misconception is that these open graded friction courses are laid above the dense graded layer. So the question of water entering into the subgrade, weakening subgrade does not arise. So above my bituminous concrete, which is a dense graded impermeable layer, I provide an open graded friction course. So this open graded friction course lets the water out of the pavement system without entering into the bottom layers. So therefore, OGFC will not allow the water to get into the lower layers and causing a damage as you have perceived. What are the alternatives if you don't get the GSB grading in the proposed grading 3 or 4? I think it's only a question of mixed design. It's a question of how it's mainly there are only 4 gradations in the table. If the aggregate gradation is not available, then what I can now say is that you can go in for even a cement stabilized subbase, CTSB, with about 1.5 to 1.75% cement. You will be able to reduce the thickness of the granular subbase from 250 to 150. So you are benefited by having a reduced thickness, reduced virgin aggregate consumption, and an improved performance because subbase is stronger. The other alternative which I can suggest to you will be, you can go in for a geocell, as I have successfully adopted geocell. I did not show that today. In that granular subbase layer, have 150 millimeter of a geocell, stretch it, fill that with aggregates, which may not fulfill the GSB gradation. Does not matter. Because aggregates are confined, the geocell has got perforations, it lets out the water there. So in situations where you are not able to achieve the desired gradation, either you can go in for a cement treated subbase, or you can go in for a geocell filled with aggregates with a slightly off the gradation. Gradation is not very important. Anything else you have? That's all the questions I have. What are the alternatives if you don't get? That's all the questions. Anything else? Anyone wants to ask?
So again, we have one question, sir.
Yeah. Where?
By Kishore Kumar, sir.
Provided specifications unsuitable, such as BMPMC for the strength of the code, allows engineer to make mistakes. I do agree. That's why we are trying our level best to remove the specification from the code of practice so that you will not adopt. But there are some people who still feel, I constructed 1960s like that. If they are the members of the committee, they are not allowing us to change this. That's why we don't recommend any of this. It is the engineer, quote unquote, who has to decide what is required. It's the designer who has to decide what should be the layers. So do not adopt this while the design stage itself. Then problem is sorted out. Even though it is specification, does not mean that you should adopt. The code has got a Fox seal. Code has got a slurry seal. Code has got a microsurfacing. Code has got a surface dressing. Are we adopting? No. Can I adopt them? Yes. Why are you not adopting? Lack of knowledge. So the one way of improving the performance of pavement is by adopting the right material for the right pavement at the right time. Cheaper treatments are available, better treatments are available. For a rural road, a surface dressing will be adequate, cheaper, but people don't want cheaper treatments. That is the other side of the story. Because there's a lot of money involved in road construction, they don't want a cheaper treatment. But when the materials are not available, I think you may have to resort to this. So there are different options available. You have to adopt them. Shopna, I think that's all the questions.
Sir, again, one more question from Ranganath Kanta. That is the last question.
Is there any method to monitor the achieved compaction remotely in the field? Will you suggest if there is one? I think that's a good question. To answer your question, now there are intelligent compaction possible. Compactometers are fitted to the rollers. So the compactometer will be able to measure the density of compaction at the site. These rollers or compactors are fitted with GPS. So they try to adjust the amplitude frequency automatically. So from that rebound that they get, you will be able to calculate what is the density that is achieved. So with this intelligent compaction equipment, intelligent compaction rollers fitted with the GPS, you should be able to ensure adequate compaction sitting remotely in your office. This is the future. Definitely in US they are attempting, but because the cost implications, our contractors are not buying this. These machinery are available. I think it is possible. That's a good question that you posed. It is possible to monitor the quality of construction sitting remotely in your office. Yeah, that's all the questions.
Yes, sir. I think that's the question.
Yeah.
So thank you very much, sir.
So thank you very much. In case if you have any questions, otherwise also you can post me the questions. I'll be able to answer through email. I'll be able to answer your questions.
Yeah, sir. Again, Ranganath has asked, shall we adopt it for rockfill dam compaction?
You can adopt wherever you want a higher density. I think it should not be an issue. You will be able to do it. But only thing what I suggest is that wherever you are able to compact, ensure that in case of soil, we say not more than 250 millimeter as a loose thickness. But up to 500 millimeter, it should be possible with the heavy duty compactors or rollers. Beyond that, even though you achieve a higher density at the top, density at the bottom will be lower. With the result, it becomes permeable. So layer by layer compaction is the simplest solution. But adopting the right roller, I think vibrate roller, you will be able to achieve any amount of compaction anywhere that you want. Yeah.
Thank you, sir. Thank you very much, sir.
Yeah.
So participants, is there further any doubt? Means you can just mail to our Dr. Rajan sir also. So we will be let you know to the Dr. VEERARAGAVAN sir.
Yeah.
So thank you all the participants. Thank you, sir.
Thank you. Thank you. Thank you.
Thank you, sir. So the feedback link has been posted in the chat box for this session. So kindly fill your feedback for the session. So we will be resuming for the next session by Mr. Rajasekhar sir. So he is our resource person is also present in this section also. So we will be meeting shortly within 10 to 15 minutes for the next session.
Okay, thank you, Shobna.
Thank you, sir. Thank you very much, sir.
Hello.
Hello, sir.
Shobana ma'am, sir is there or left?
Yeah, sir. VEERARAGAVAN sir has finished his session.
Yeah, sir is there or left?
I think sir is left, sir. Now only sir left.
Yeah. No issues. Okay.
Yes,
I will talk to him.
Okay.
You thanked him, no?
Yeah, sir. I thanked him, sir.
Okay. Sir has come, Rajesh sir.
Yes, sir.
has
I
come.
think Rajashekar is also in line.
Yeah. Sir,
Hello,
welcome, sir. Dr. Rajashekar, Mr. Rajashekar, sir. Are you there? Hello. Sir?
Sir, I'm
Thank you. Thanks for joining.
Yeah, I'm just sharing my screen. Just you can accept.
Yeah, please, Shobana will help you, sir.
Yeah, sir. Yeah.
Shobana, please help him. Help, sir.
Yeah, sir. Fine. I will take this.
You can hear now, madam. You can hear everything.
Yeah, sir. I can able to hear you, sir. No problem.
Yeah. Just I'm sharing my screen. Okay.
Yeah, and you can wait for 5 more minutes and then we can start, sir. Because the scheduled time is 11:30. We can start a little bit according to our thing. Like, if participants want 10 minutes break, we'll give a break. It's not an issue. Shobana, you plan accordingly. Fine?
Yeah, sir. Yeah, sir. Fine.
Because I told you, I'm in Abuja today, so that's why I'm not able to be continuously available there. So I'll join back again by around 12 o'clock. I will join, sir. Sorry, I am missing your session, but the recorded version is available.